Welcome to the DIY Honda Garage channel. The DTC P2184 refers to an issue with the Engine Coolant Temperature ECT Sensor 2 circuit, signaling low voltage. This diagnostic trouble code indicates that the ECT Sensor 2, which plays a critical role in measuring the temperature of the engine coolant, is not functioning correctly. The sensor's data helps the Engine Control Module, ECM, adjust the engine's fuel and timing for optimal performance. Typically, the ECT Sensor 2 is found near the thermostat housing in the engine bay of the Honda Accord. The readings from this sensor are essential for ensuring that the engine operates efficiently and avoids overheating. It is important to remember that low voltage readings can indicate wiring issues, poor connections, or a faulty sensor itself. Before proceeding with troubleshooting, it's advisable to record all freeze data, which captures the vehicle's operational status when the code was triggered, along with any onboard snapshot that might provide further insight into the situation. DTC P2184 highlights a problem with the Engine Coolant Temperature Sensor 2, often referred to as ECT Sensor 2, located close to the thermostat housing of the Honda Accord. This sensor is tasked with measuring the temperature of the coolant flowing through the engine. Its primary function is to relay this temperature to the Engine Control Module, ECM, allowing for adjustments to fuel injection and ignition timing based on engine operating conditions. If the ECT sensor fails to provide accurate temperature data, the engine may not run efficiently, leading to poor fuel economy or potential overheating. Moreover, the connection points where this sensor interfaces with the wiring harness are crucial. Any loose terminals or poor connections can disrupt the data flow to the ECM. Therefore, proper inspection and troubleshooting of this component and its connections are essential when addressing this DTC. The potential causes of DTC P2184 primarily involve three areas: the ECT Sensor 2, wiring issues, and connection integrity. A faulty ECT Sensor 2 is one of the most common culprits, as wear and tear over time can affect its ability to measure coolant temperature accurately. Next, wiring issues are another significant factor. This could include damaged or frayed wires, which can cause intermittent or complete loss of signal. Lastly, loose connections at both the sensor and the Engine Control Module, ECM, could result in poor data transmission. Addressing these causes requires a thorough examination of the wiring harness, connectors, and the sensor itself to ensure proper function and reliability. In some cases, simply correcting the connections or replacing the sensor can resolve the issue. It's vital to approach troubleshooting systematically to identify and rectify the problem effectively. The symptoms associated with DTC P2184 can vary, but typically include increased engine temperature readings, poor fuel economy, and the illumination of the check engine light on the dashboard. An inaccurate temperature reading from ECT Sensor 2 can cause the engine to overheat, which can lead to serious damage if left unattended. Furthermore, the ECM may respond to erroneous data by adjusting fuel mixture improperly, resulting in decreased fuel efficiency. Drivers may notice that the vehicle seems to consume more fuel than usual, or might perform poorly during driving. In addition, the activation of the check engine light serves as a crucial warning that something is amiss within the engine management system. Monitoring these symptoms can guide the technician in identifying the root cause and facilitate timely repairs to avoid more extensive damage. The first troubleshooting step involves turning the ignition switch to the on position, which is the second key position, 2. This action powers up the vehicle's electronic systems without starting the engine. Next, technicians are instructed to check the ECT Sensor 2 data using the HDS, or Honda Diagnostic System. This system interfaces with the vehicle's onboard diagnostics to display real-time data. At this point, you need to determine whether the data indicates a temperature of about 356 degrees Fahrenheit or 180 degrees Celsius, or if the voltage reading is 0.08 volts or less. If either of these conditions is met, it further implicates that there is a problem within the ECT sensor circuit. Should the readings indicate otherwise, it suggests an intermittent failure. In this case, it's recommended that you check the connections and terminals at the ECT sensor 2 and the ECM. For the second troubleshooting step, the procedure begins by setting the ignition switch to the lock position, which is the first position, 0. This step ensures that the ignition and all related electronic systems are completely powered down, crucial for safety. Afterward, the ECT sensor 2p connector needs to be disconnected. This is typically located at the sensor itself. Once the sensor is disconnected, the ignition switch is to be turned back to the on position, 2, again. At this point, you will again check the ECT sensor 2 using the HDS. You are looking for readings of about 356 degrees Fahrenheit, 180 degrees Celsius or less, or a voltage reading of 0.08 volts or lower. If the readings persist at these thresholds, you will proceed to the following troubleshooting step. However, if the readings are normal, it may indicate an intermittent failure, suggesting a need for checking poor connections or loose terminals affecting the electronics. In the third troubleshooting step, the ignition switch is turned to the lock position, 0, once more to ensure safety before proceeding. After confirming that the ignition is safely off, the next task involves jumping the SCS line, which refers to the SRS connector shorting line. This procedure is essential for safely performing certain diagnostic checks with the HDS. Once the SCS line is jumped, technician must then disconnect the ECM-PCM connector A, labeled as 49P, which interfaces with the engine control module, powertrain control module. This step is crucial because you need to test for continuity in the circuitry. Following this step, further diagnostics can lead to identifying whether there is a short in the wiring between the ECT sensor 2 and the ECM-PCM, a critical factor in determining the source of the low voltage issue. The fourth step of troubleshooting requires checking for continuity between the ECT sensor 2 2P connector and body ground. Continuity testing ensures that the electrical path is complete and that there are no breaks or shorts in the wiring. Technicians must particularly check terminal number 1 at the 2P connector. If continuity is confirmed, this indicates that the wiring between the ECT sensor 2 and the ECM-PCM is faulty, requiring repair of a short circuit. This may involve replacing damaged wires, connectors, or fixing any shorts observed in the wiring harness. If no continuity is identified, it leads to a different diagnostic path that suggests that the ECT sensor may need replacement instead. This step is essential to isolate the issue further and prepare for an effective resolution. The fifth troubleshooting step involves turning the ignition to the lock position, 0, for safety before any repairs are made. If continuity checks or previous tests indicated a faulty ECT sensor 2, the sensor must be replaced. This involves disconnecting the current sensor, removing it from its mounting, and installing a new, compatible ECT sensor. After replacing the sensor, it's crucial to reconnect all electrical connectors securely to ensure proper operation. This includes the 2P connector for the ECT sensor, as well as any other relevant connectors that were disconnected during earlier steps. This step ensures that all components are back in their original operating state. Consistent checking at this phase prevents any potential reoccurrence of the issue due to improper reconnections. final repair verification is essential to ensure that the new ECT Sensor 2 has resolved the low-voltage circuit issue denoted by DTC P2184. Start by turning the ignition to the on position 2 without starting the engine. Following this, the ECM/PCM must be reset using the Honda Diagnostic System, HDS. This reset is vital as it clears any pending trouble codes and refreshes the module's learned parameters. Additionally, it's critical to perform the idle learn procedure after resetting the ECM/PCM. This procedure fine-tunes the engine's idle settings to operate efficiently with the newly installed sensor. After completing these steps, checking for any pending or confirmed DTCs with the HDS will confirm whether the issue still persists or if the problem has been rectified altogether. Preventive maintenance is essential in preventing future instances of DTC P2184 and maintaining optimal engine performance. Regular inspection of the ECT Sensor 2 should be carried out to look for signs of wear or damage, which can help in catching issues before they escalate. Along with the sensor, examining the associated wiring for frays or corrosion is also crucial. Such wear could lead to intermittent or low-voltage signals. Ensuring that all connections, especially those leading to and from the ECT sensor, are firm and secure can help to avoid poor data transmission or electrical faults. Implementing a regular maintenance schedule that includes these checks can extend the life of the ECT sensor and reduce the likelihood of future diagnostics stumbling upon similar issues. In conclusion, diagnosing DTC P2184 requires a systematic approach that emphasizes the importance of each step in the process. From checking ECT Sensor 2 data readings to performing continuity tests, each action contributes significantly to pinpointing the root cause of low-voltage signals. The condition of the wiring and connections cannot be overlooked, as these are often the source of intermittent problems. Regular maintenance contributes significantly towards preventing such issues from arising in the first place. By performing these routine checks and understanding the function of the ECT sensor, technicians can ensure that the engine remains in optimal condition and operates efficiently. Addressing these concerns promptly not only improves vehicle performance, but also helps avoid potentially costly repairs down the line. Please like and subscribe to the channel. See you next time.